What is happening in number 13? What is that? Yeah, it's multiplying by -2 each time. Is that what you said? And then you said no, but it was. Okay. Okay, so go like this times -2. Can you guys tell it's multiplying by -2 each time? Okay, now, does anybody remember what it's called when it's a multiplication one? Geometric. Nice. Okay, geometric has a little bit of different letters. So the growth, the multiplier is R, and R is stands for common ratio. So arithmetic ones have D, which is the common difference, and R ones have geometric ones have R, which is the common ratio. Okay. Now, the second step is the same as the first step. So I found the growth. I said that it's geometric, and then I have to go backwards one spot. So I make my arrow back. And what number would be in front of this sequence? Yeah, positive 1.5. Okay, and that's term 0 is 1.5. And geometrics are exponential. So the equation looks like T of n equals term 0 times R to the n. Are you guys okay? Okay, so this one is y equals mx plus b, and this one is y equals ab to the x. Okay, and last thing, we need to find term 12. T12 equals 1.5 times -2 to the 12. (1.5 times -2 to the 12) is 6,144. So if I kept going out to the 12th number, it feels like that's kind of big for the 12th number, but I guess it would be 6,144. Okay, that's the only warm up we're doing today. Next, I want to ask you, do you have any questions from any of the stuff we've been working on that you wanted to ask me? The quiz review, the worksheets. Take a look through your packet. See if there's anything you want to ask me about before we do today's stuff. You found it?
No, I'm trying to find it.
So, is it possible that this is your packet?
That is very possible.
Is it possible that you were sitting at the table that left the entire top of it trashed yesterday with trash and food and stuff that they didn't put away in this packet? Because they think that I'm their mommy and that I'm gonna clean up after them when they go?
The man goes next time.
That's like, I take 2 minutes to work on something myself. All chaos breaks loose. Okay. Now the packet has returned to its home, which is good. Next question. Do you have any questions though? Like seriously, math questions about the packet or anything in there? Anything at all? Any of the questions? Yes, honey. 37. Okay. 37 is the one that's 40 questions, I'm assuming. Okay. 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 Do you know what type of problem this is? Do you know the name of it? Like what the test topic name is? Perfect. Okay. That's half the battle for sure. Okay. So, did you draw your axes, honey? Do you know to draw axes? Okay. So, and then does it make sense when I said I put x's by cosine and y's by sine for now because we're learning? Okay. Now this is the hardest part of the whole problem. I'm going to translate it to figure out what quadrant it's in. I don't know, you guys tell me, but I think that's the hardest part. Okay. So I'm going to make like a little coordinate, fake coordinate. Okay. This says if y is a positive and x is less than 0, so x is a negative. Okay, which quadrant is negative then positive? Quadrant 2. And make your just any generic right triangle in quadrant 2, but it has to be the shape of the bow tie. Okay, now this time is different from the other times. It says if y is 3/5, that's going to go on the height because y is the height. And it says find cosine, which is the x, and then the hypotenuse is what? Okay, Ava, what do you want to ask me? Okay, but I mean about anything I've done so far, I meant. You're okay so far? Okay. So x squared plus y squared equals 1 squared. You're probably fine after now, but I'm just going to keep going. X squared plus 9 over 25 equals 25 over 25. Okay, Ava, does my 25 over 25 make sense? Okay. I just really skipped a step there. Also, how many views did you get? Really? That's great. Sorry. Super excited. Okay. Does it make sense so far? So I minus the 425s from both, 925s from both sides. And now I have 16 25s. Square root. Yep. Okay. So this is really important to me that you remember that it's plus or minus, but then you choose the sign. So you can do it one of two ways. You can go up to look at the coordinate and be like, oh, x is negative, so I need to choose the negative one. Or you can do it visually and see that your triangle's going in this direction, which is negative. Either way, final answer, cosine theta equals negative 4 bits. Does it make sense too how I took that x and then replaced it back? Okay.
This one was good.
What?
This one was good.
Yes. This one is on the quiz. Of course. And see how you feel about number 38 when you try it. I'm gonna give you guys time later to work on stuff, so see if you can get that one. I think you guys tell me if you agree with me. The hardest part about this whole problem is just figuring out the quadrant. No? What's the hardest part? Yes. Okay, that might be the hardest part. Okay. I don't know. I don't know. Once you guys get a few of these under your belt, they're not that bad. But I have to give you some foreshadowing. They get worse. They get worse because I don't know if you noticed, this comes out nice on the problems we're doing right now. So that's not always going to come out nice. Okay, so take a look at the stamp sheets. Anyone else? Sorry, I didn't mean to just move on. Any other questions from any of the worksheets or anything? You guys can ask me stuff individually later too, after we're done with the lesson. Okay. Let's look back here. Just want to make sure that we're completely clear on what we're doing. So I took off the CPM problems that were supposed to be homework tonight, and you're just going to finish that worksheet. And I'm going to stamp on Friday before your quiz everything up to here. Does that make sense? So you need to have the mid chapter done, 60 to 64, 65 to 68, the maze, that worksheet, and then 72 to 75 is what we're doing in class today. It's really not that bad. I promise. It's not that bad. I actually jumped. It's not, yeah. I think it's, I gotta think about what the W is. Okay, here's a fun thing. The 72 to 75 is not in your notebook. So if you guys could get a green page. And label it up here just so that you know. Okay, guys, I need you to pay attention, please. And then each person needs a strip of triangles. You need one 30, 60, 90, and one 45, 45, 90. So take a look in the middle of the table, and you're gonna have to cut them apart. So each person gets two triangles. Yeah. Violet's already on to me. She already knows exactly where this is going.
I never received that. We did this last
Yeah, yeah, you did.
year. I didn't. Highlight. Extra two. We're opening that into this 30, 60, 90, or 25. Yes, Philly.
Okay. Hi, everybody. So just make it a strip like mine, and you know, come out, don't come out yet, don't come out yet. We're gonna do math on the paper. We're still gonna cut them out, so you're not, it's just not yet. So just find spots, just a blank spot to write. Okay. My goal is, before we finish this bit, is to figure out what the other two sides would be if the hypotenuse is one, using special right triangle formulas, not SOHCAHTOA. And then to label all of the sides and angles, but not outside of the triangle, inside of it, because we are going to cut it out. But we want the labels. Okay. What? Don't cut them out. Not yet. Okay, because I'm going to do a little bit of math first. Shh. Does anybody remember the 30, 60, 90 formula?
No.
Okay, where does the 2x go?
This was on the, usually the hypotenuse.
Not usually, always the hypotenuse. Well, I mean the formula. Okay, so let's pretend that I see what you're saying. Let's pretend the one's not there. Okay, so put the 2x there. Sam's in charge. What goes next? Yeah.
The root 3 goes on the bottom.
Yep. So x root 3.
And then that.
Beautiful. He's doing great. Okay. So this hypotenuse is 1. What I want you to do is transfer the length of 1 inside the triangle, because we're going to end up cutting this out. And if we cut it out with the labels on the outside, it's not going to do us any good. But we are going to find the answers on the outside. They're going to go in the trash. It's going to be fine. Okay. What I like to do when I solve these is I like to say which label lines up with a value I have and make that into an equation. So I would say The 2x side is 1. The 2x side is 1. Okay. Divide by 2. X equals 1/2. Okay, label that 1/2 inside the triangle next to the, my 1 looks too much like a 2. Yeah, yeah, can't do it. Okay, and then while you're at it, put the 60 up here. That's going to help you later. Okay, now that we know that x is 1/2, I'm going to take that and plug it in for x right here. Yeah, and then I'm going to do 1 times √3 is √3 over 2, and label this side √3 over 2. Okay. Now we're going to do the next one. We're going to cut it out soon. Don't worry. It's going to be fun and exciting. Transfer the 1 inside. 45 degrees up there. Okay, anyone other than Sam remember the 45, 45, 90 formula? Ankita, what is it? Okay. X √2. And you said the other sides are both X? And this one's good because we only really have to find one thing, which is great. Okay, now these two line up together. So I like to do the same thing. I say X √2 equals 1 because the X √2 side is 1. So X √2 is 1. Okay, now this is where it's going to get a little spicy, but here's the thing. Pause real quick. Do you remember that foreshadowing I told you about in the Pythagorean identity problems? I was like, notice how they're coming out all nice, but they're not always going to come out all nice. This is the situation in which you will find yourself. Okay, so divide by √2, divide by √2. Oh no, there is a root in the bottom. I am not allowed to leave a root in the bottom. What do I do? Giant 1, right? Does anybody know what doing this is called, the proper vocabulary for it? Dude, you're on fire. Rationalizing the denominator. It means making the denominator a rational number. Okay, so 1 times √2 is √2. Here's a hard question. What is √2 times √2? Yes. Okay, now if you need to, you can think about it being √4, and √4 is 2. Okay, so both of these sides are √2 over 2. Okay, now here's what I would like you to do next. I would like you to cut out the triangles and be very careful. I want to label the other sides the same things as these sides. So take your triangles, cut them out. You might have to take turns because I don't have enough scissors. Do you guys see what I'm doing on the other side? Do you know does that make sense? I'm just labeling the other side the same stuff. I labeled the original side. So if that's one half, then that's one half. And you guys might have noticed that some of you have different orientations of the triangles than other people. So now we'll have exactly the same step because we're doing both sides. Okay, now I'm going to ask you very kindly to recycle your extra pieces. Do not put your extra pieces in the baskets. Do not put your extra pieces on the floor. Do not scatter your extra pieces under the table. Make sure that your extra pieces make it to the blue can, please, and thank you. Oh, you're not literal enough for me, Mrs. Talbot.
Well, yeah, I cut them out. Same. Okay.
Guys, you ready? This should not be difficult. You walk over to the can, you put your extra stuff in there. You feel weird about throwing away your math problem, but that's okay. I just wanted to remind you how we got these. Okay, that was problem 72, making the triangles. So does that make sense to everybody? We're done with number 72. We have our triangles. Okay, now we're going to start to fill out this resource page. This guy's going to become your best friend. That's why we made him a different color than usual and outside the packet. This is kind of like the blue sheets that you kept through all of first semester. This is going to be something that you're going to pull out every time that you're working on math for a while. Okay, so the first thing I want to do is start with the coordinates on the axes. Okay, so this is very specifically saying that this is the unit circle. If it's the unit circle, what is the radius? 1. The radius is 1. Guys, please. That means that this is 0, 0, and this is 1, 0. The top would be 0, 1, because this is 0, 0, right? Negative 1, 0. Yep, 0, negative 1. Okay, and I like to start with this because I want you to kind of imagine that you have gigantic graph paper and this fit into one graph paper square. Do you see what I mean? Actually, it would be 4 graph paper squares if I drew it the normal way, if I made it like and then made my circle. Okay, so just pretend that these are like, it's got giant graph paper. Okay, we're gonna start with the easiest part for everybody, which is the degrees. I feel like that's probably where you're most comfortable. And we're gonna start here. We're gonna say that's 0. Go up here, that's 90. Make sure that you're writing in the blanks with the degree symbols. 180. 270. Okay, pause there. Do all of those entries make sense? 0, 90, 180, 270. Okay, now we're gonna work on just kind of counting. So this is straight down the middle. So that's 45. So 0, 45, 90. And then these two are 15 degrees on either side. So this is 30 and 60. And I really want you to see how that ties into the triangles we made. We made a 30, 60, 90 and a 45, 45, 90. You guys okay with that? Okay, so if this is 90 and this is 180, what's halfway? 135. Okay, and then these are 15 degrees on either side. Yep. Okay, what's halfway between 180 and 270? 225. Which would make this one 210 and 240. And then what's halfway between, oh, snap. I forgot, look, I forgot my co-terminal. They even made me a 360 spot right there. I know, forgot. Okay, 315, which means that this is 300 and 330. Okay, just pause right there. Are there any questions about what I did so far? I want to make sure we're solid as we go, and I don't want to lose you in any of the spots. You're good so far. We promise, we double promise, triple promise, pinky promise. Or whatever, that one. Okay. That was problem number 73, believe it or not. It was way too easy. Okay. I know. It's my favorite. Okay, now next. Let me ask you what you think these other blanks are for.
Radians.
Radians, nice. Okay, all right, so this is harder because children, fractions, everyone's favorite. 0 is easy, that's 0 radians. 180 is pi radians. And then 360 is 2 pi radians. Okay, so those were completely set on. And then what I'm going to do is I'm going to zoom into the top of my circle. I'm going to slow down and focus on this. Okay, so we're only looking at the 0 to pi right now. What would halfway from 0 to pi be? Half pi, but I'm going to call it pi over 2. Half pi is pi over 2. Okay, now what would be halfway between 0 and pi over 2? Pi over 4. Okay, so now what we're going to do is we're going to stop here and we're going to go all the way around the circle. We're going to use that tool that I taught you the other day when we were working on the sine graph. Okay, but we're only going to do the 45 degrees is. Okay, so count with me. 0, 1 pi's over 4, 2 pi's over 4, 3 pi's over 4. Oh, it's ugly though. And then 4 pi's over 4. You're not wrong. You're not wrong. Okay. Then 5 pi's over 4. 5 pi's. Yes. Okay. This would be 6 pi's over 4, but 6 pi's over 4 would reduce to 3 pies over 2. 7 pies over 4. 8 pies over 4 is already there. Okay, now I know that that's kind of, it's new. I don't want you to think again that I'm being condescending in any way, shape, or form, or that I think this is easy. So I'm just gonna say it again, 0. 1 pies over 4. 2 pies over 4. 3 pies over 4. 4 pies over 4. 5 pies over 4. 6 pies over 4. 7 pies over 4. 8 pies over 4. Many pies over Mrs. Talbot delicious want to eat pies. Okay, now we're gonna count every 30 degrees. Okay, it's gonna be 5. Okay, can you visualize the 30-degree jumps? So 30, 60, 90, 120, 150. Okay, 30 degrees is pi over 6, just to get you started. That means that I took the top half and I broke it up into 6 equal pieces. Okay, so we're gonna go, and you guys, you can stay silent because I don't want anyone to get nervous. Okay, 1 pies over 6, 2 pies over 6. Does everyone see my 2 pies over 6? Okay, now we already wrote the 3 pies over 6. 4 pies over 6. 5 pies over 6 cannot be reduced. 6 pies over 6. Yep, you're doing it. 7 pies over 6. 8 pies over 6. 9 pies over 6 is already labeled. 10 pies over 6. 11 pies over 6. And 12 pies over 6 is already labeled. Okay. I'm hoping you can see this pretty well. Just check up there to make sure we have the same thing. Here, I'll zoom into the top and then I'll move it. Just check your values on the top. Make sure we have the same thing. And then check your values on the bottom. Make sure we have the same thing. How long have you been done? Okay. All right. We're not done yet. There are some coordinates missing. You guys are like, we went through all the trouble of making those triangles. This is what the triangle bit is for. And then we need to talk about sine and cosine after that. Okay, so what I want you to do is come back to quadrant 1. And I want you to tuck your 30, 60, 90 triangle into that spot with the 30-degree angle. Oh, Mrs. Talbot, you and Miss Rice, you really made this a super precise triangle for this resource page. Oh, indeedy, we did. Okay, so the way we find the coordinate is to go over and up. So let me say that again. The way we find the coordinate is to go over, then up. So this coordinate is √3 over 2, comma 1/2. Does everybody see where I got √3 over 2 and 1/2 from? Okay, now grab your 45, 45, 90 triangle, tuck him in this spot. There's no pies. Yes, yes, yes. Okay, so over. Oh, why is that not pretty? So over and up. But does it make sense that that coordinate would be the same thing? X and Y, because you go over the same amount that you go up. Okay, now you're going to take your 30, 60, 90 again, but you're gonna have to flip him over. And that's why we labeled both sides. So you could flip him over and tuck him in to the 60-degree spot. Okay, so this coordinate is over 1/2 up √3/2. Okay, so now flip this, like reflect it across the y-axis, so it's over here, and then you're gonna see the triangles are not gonna be super important anymore. Yes, okay. Sean's he's already on it. This is quadrant 2. Quadrant 2 is back and up. So this is negative 1/2 √3/2. Negative √2/2, positive √2/2. Do you even really need the triangles anymore after this? You could kind of pick up the pattern that it's the same as the other side. Do you guys see what I'm saying? But we took all the time to make the triangles. I know. Okay. Now we're in quadrant 3. Here's my setup for quadrant 3. My stuff's upside down. It'll still work. But what about the signs of things? Mm-hmm. Okay, remember that when you're doing the coordinate, it's over first and then down. Over and down. Okay, now what about quadrant 4? What about the signs? Yeah, so over, positive, negative. So seagulls are out. Oh my gosh. Okay, that was problem 74. We have one more problem to do. Check your values, make sure they look like mine. My value's wrong. Was anybody gonna tell me? I forgot the negative. Okay. So we need to add stuff about sine and cosine and the quadrants. Okay, so what I think is helpful is for us to come back to quadrant one and put plus, comma, plus. Do you know what I mean by this? The x values are positive and the y values are positive. And this will help with your Pythagorean identity stuff too. So x's are negative, y's are positive. That's a winky one. This one, both eyes are open. This is a winky. Mm-hmm. Okay, so I think that's really helpful. But then I also think, but come back up to the top, we're going to write cosine of theta equals x. Sine of theta equals y. Leave some room because we're going to add tangent to this at some point, not today. And then what I want to do, the last thing is go around to the positive and negatives. Okay, so right next to this, we're going to say cosine and sine, which is positive, which is negative in this particular quadrant. In this quadrant, does it make sense to you that sine and cosine are both positive? If cosine is x and sine is y, then cosine and sine are both positive. Do you see where I'm getting that from? If that's cosine and that's sine. Okay. In this quadrant, cosine is negative, sine is positive. In this quadrant, they're both negative. And in this quadrant, cosine is positive and sine is negative. And on Monday, we're going to come back and add tangent to all this stuff. Do not lose this paper. Okay, last thing. Last bit for this paper. What I want you to do is glue stick your triangles in the space at the bottom. You don't need this website. Glue stick your triangles in the space at the bottom. Because we're going to use these triangles a lot. You're going to want to be able to come back to those. You don't need both sides because you're smart enough to look at what's the long side and the short side, and we're good. We're good at this point. Okay. And then after we're done, I'm going to give you a 30-second oral pop quiz that has absolutely no meaning on your grade whatsoever or anything about what we just made. So my two kids went to this high school and they took math 3. I had my son in my class and they thought it was hilarious that I had this thing memorized. And they would yell at me from the back of the seat like I was a trained circus animal to read to give them pieces of this just from my brain because they thought it was just a miracle that I could memorize this thing. It's really just not that big of a deal because they're all the same things. It's just negatives and positive, whatever. It made me feel very smart. Like I could go on America's Got Talent and, recite the unit circle. Okay. So you guys look at your unit circle. This is the kind of question I'm going to ask you. Looking at the unit circle, what is the cosine of 45 degrees? Looking at the unit circle, what is the cosine of 45 degrees? Root 2 over 2. Okay, so you go up to that little thing and you say, oh, the cosine is x, so I'm going to look at the x coordinate. You guys see what I'm saying?
Mhm.
Okay, what is the sine of 180 degrees? What's the sine? Zero. These are the kind of questions that you're going to be asked. So you need to know like how to, okay. What is the radian at 330 degrees?
11 pi over 6.
Yeah. What is the sine of 330 degrees? What is the sine of 11 pi over 6? Yeah. Do you see what I'm asking? So when I'm asking for sine or cosine, I'm asking for the coordinate. Yes, honey. No. Okay. I never ever require you to memorize this thing. If you like it, okay, what actually works best for my students is just to know the 30, 50, 90, 45, 45, 90, like the length of the side. On the test, remember you have a note card. If you feel like you just want it on your note card, you could, but I don't think you ever made a problem where you needed to have it on the note card. You guys notice how there's a second page of warm-up? Yeah, those are all straight off of this. So I promise you there's gonna be enough practice and repetition where you're gonna be able to do it. You don't need to be the trained circus animal like the teacher, although it is funny. To ask me weird crap and then have me just be able to give it to you. The reason that I know the unit circle is because I know a 45, 45, 90 is the same. And I know a 30, 60, 90 has a short and a long. And that's all you need to know is the short and the long are the same. And then you can recite the whole thing. But again, oh, also there's a trick. Okay, watch my trick. It's great. It's great. Ha. Wait, lie. Ha. Okay. 0, 90, 45, 30, 60. Right. And then over, up, long, short. Yeah. Anyway, there's a hand trick that you can like, okay, like you just make this the x-axis and make this the y-axis. 0, 90, 45, 30, 60. Yeah. Anyway. You guys can Google that or go on YouTube and look up like the hand trick for the unit circle. It's really fun. And if any of you do it during the test, that's gonna be great. No. Okay, so it's 12:20. You guys have a half an hour to work on your worksheets. Classwork is done.